And good afternoon. Katya, you have the ball.
Thank you, Bill. Good afternoon, everyone. And I'd like to welcome all our participants and presenters to our webinar on STEM and ELS, a collaborative effort. Today's webinar is hosted by the National Clearinghouse for English Language Acquisition, NCELA, located at the Graduate School of Education and Human Development at the George Washington University, and funded through a contract with the U.S. Department of Education's Office of English Language Acquisition. Our mission here at NCELA is to provide technical assistance information to state and local educational agencies on issues pertaining to English language learners. My name is Dr. Katya Flemons, a Senior Research Associate at NCELA and your webinar facilitator for today. Welcome, everyone. First, I just have a few reminders. The contents of this webinar, including information or handouts, do not necessarily reflect the views or policies of the Department of Education, nor does the mention of trade names, commercial products, or organizations imply endorsement by the U.S. government. Also, if participants would like to submit their questions, please submit them during the webinar by clicking the third tab on the top right-hand corner of the screen, that says Q&A, and question and answers are to be submitted in the chat box in text format. Okay, and on to our presentation for today. Our presenter is Dr. Paula Hooper, who works as a senior science educator and learning research scientist in the Institute for Inquiry at the Exploratorium. And today we're going to be discussing different ways in which we can engage and help English language learners to be successful in science, technology, engineering, and math, also known as STEM, and what does that involve? And that basically involves all of us collaborating together. And what we mean by collaboration in today's webinar is looking at how science learning and science educators and English language development can collaborate and be integrated together to help engage ELS in STEM. Another thing that we will discuss, that Paula will discuss, is a project that is currently going on at the Sonoma Valley Unified School District, which is looking at collaboration between science educators from science-rich educational institutions and science educators and EL educators in local educational agencies. So Dr. Paula Hooper from the Institute of Inquiry, which is located at the Exploratorium, will present to us today how we can better support and integrate science learning and English language development, to engage ELS in STEM activities. Welcome, Paula, and thank you for presenting today.
Thank you, Katya.
You're welcome.
Okay. Well, first, I'd just like to say it's a pleasure to share with the NCELA community. I'm just very honored to be asked to share some of our ideas from this new project that we've started. I just have a few caveats to help orient people to the types of things that I'm going to be talking about today. On this slide, you can see this is a wonderful collaboration between the Exploratorium, which is we call the Museum of Science, Art, and Human Perception in San Francisco, and the Sonoma Valley Unified School District. We came together in this collaboration because the teachers and the superintendent a few years ago was concerned about the development of the progress in English language development of students in their school district, and our lab work is with kindergarten through 5th grade students, and feeling that over time their SELT score, the English language development test in California, weren't progressing a lot, and the resources that they were using to support students' English language development were not as effective as they wanted them to be. So they came up with the idea that maybe science would be a good way to at least give students something interesting to talk about. And that's become a theme in our work that you'll see. And it started with motivation from the superintendent and the teachers in this school district and the principals saying, let's try something different. And they came to us because our expertise is in science learning and in professional development around inquiry-based hands-on science. So I'm speaking from our perspective on this work. We are new to the field of English language development, and we are working with several partners to help us develop this work. Definitely the resources within the school district. We also have a research and evaluation team that's working with us, Inverness Research and the Center for Research and Evaluation and Assessment at Lawrence Hall of Science, as well as people that we've called on from different parts of the English language development field in particularly to help us. So I just wanted to put that caveat out there that I'm coming from the science education perspective into trying to bring our ideas towards English language development. The other caveat is that this is a new project, so it's funded by the U.S. DOE Investing in Innovation grant, one of the I3 grants are sometimes called, or Educate to Innovate, and we just began this project. So it's great to share where we're starting from, and I hope that it will, and I believe that we'll have more detailed stories to tell over the 5 years of this project. But these are our beginning ways of thinking about bringing this integration together. And the last caveat is that this is my first time doing a national webinar, so it's a wonderful way to get oriented to how you address an audience in this forum and work with slides and that sort of thing. I hope to try to make it as much of a dialogue as possible. For those of you who are familiar with webinars, I hope that you will really ask questions and really support getting what you need and are interested in out of the information that I'm about to share. And we noticed that there are a couple typos in the slides, and when they go up on the web afterwards, they will be revised. And if there are any ideas that come up in the conversation that might help to revise them, then I will certainly contribute those. So here we go. So as I said, we came to the Sonoma Valley Schools came to us and said, we need to do something to make our English language development work more engaging and productive for our students. And this motto came out of their work about saying, let's give them science to talk about. And they asked us to give them, and we offered to give them knowledge and resources about science, teaching, and learning, and to help be a conduit and a connection to local and national expertise in English language development. They brought their rich work around science education, a little bit around science education, but definitely around English language development. And they had an orientation that included several different strategies and approaches to English language development. There was a big thing out in California, there are lab strategies. Definitely things like sentence frames and concept maps and all those kinds of things that are in several different approaches to English language development. And we've decided to work together to create a community of learners where we're both sharing what we could contribute to thinking about the integration of English language development and science learning. So we're hoping that we will be able to create some new knowledge about how you can use science to support language acquisition and the academic achievement in science. Our goal, then, is the way we think of it in broad terms, is to explore the integration of science learning and English language development through this collaborative approach to professional development that supports the improvement of classroom practice, both in teaching science and in supporting students' English language development. The way that I'll progress through the talk is to give you some of the rationale behind our thinking once we sort of got this original excitement going about giving students something to talk about with science. We had to really begin to look through the field of ELD and some of the ideas that we have about professional development around science learning and come up with the approach to guiding the initial work that we do. So I'll go through describing the professional development work that we do to support this work, and then some of the specific classroom practice that around inquiries and how we give the teachers curriculum units and lessons to support them, really bringing this integration into their classrooms. And one of our mottos at the museum is the best answer is a question. So I will hopefully lead you on a journey that will help you understand the questions that we're asking at the beginning of this project and how we hope that we will progress towards those answers. So just to give a little bit of context about why the Exploratorium is a good place to support working with inquiry. So I know many of you have visited our museum, but we try to, in our exhibits and all of our programs, an environment where inquiry is what's leading people in their activities. We want our visitors to come up to exhibits and look and notice and do things that lead them to ask their own questions. Why is this happening? What can I do to figure out more? And so, because we know that inquiry is such a productive way for students to learn science, and the Exploratorium is built on this idea, our professional development program helps teachers to understand inquiry in a way that they can extend it into their classroom. We use the definition, particularly in our professional development work of inquiry, that it's a multifaceted activity that has all of these skills, sometimes people call them process skills of science, around observing, asking questions, planning and conducting investigations, using tools to gather evidence, analyzing and interpreting that data, proposing answers, giving explanations, and making predictions, and then, particularly importantly, stress the ideas about communicating and sharing your results, even if those results are another question. We found that all of those ideas about inquiry that do support the potential for inquiry-based science to be a good setting for nurturing language. Then when we began to look at the field of language acquisition and English language development as it's practiced in schools, we realized that there is a lot that's not figured out in as clear a way as some of our work is in science education around how you teach, what's the best way to teach, what's the best way to understand how students develop English language as their second language. And so we realized that teachers have to negotiate several different views, and we're having to negotiate several different views in order to frame the directions that we think are most productive for integrating English language development and science work. All of these ideas support that integration, but they all have different tacks, and that's actually something I'd like to talk with you a moment about once I lay these out. We began with this practical view that definitely came from the teachers, as I described. Let's give the students something to talk about that is science. And from the language acquisition view, the second language acquisition view, we realized that acquiring academic language is particularly important for students to have a purpose in using that language. And that is one of the reasons why science is an important context can be a good context for English language development, because when you're making sense of phenomena, it draws on you to use language in different forms. From the science and literacy view, we really delved into the research around this to find this basic message that science process skills are very resonant with language and literacy learning skills. For instance, the kind of interpretation that you do when you've gathered data and you're trying to make sense of it is very resonant with some of the types of work you do when you're reading and you're trying to make sense of the words on a page, which is very challenging for young children. So, and then we realized from the sociocultural view that children make meaning particularly well when they are encouraged to express themselves in ways that are comfortable for them. So the research that looks at everyday language and conversational language and how bringing that language and supporting students in using their everyday language in making sense of science as well as other disciplines in the classroom. It requires teachers to acknowledge the cultural places that students' discourse practices come from, and then to value those cultural practices in the classroom. So with all these, we sort of jumping out of these 4 different views, all of them have supports for thinking about why science is an important context for learning language, or you can be opportunistic about using science to support English language development. But there are also perspectives that bring a lot for teachers to have to negotiate in creating successful English language development environments. So I wanted to pause here and see if there are any questions or comments that people have about sort of this rationale that we've set up so far and how maybe that plays out in some of your work or further questions that you have.
Thank you, Paula. And I do encourage participants to please type in your questions so that we can ask our presenter. And Mari, do you have any questions for Paula?
Yes, Paula, and this is Mari Rasmussen at Stella. Just a quick question. This is just such wonderful stuff, Paula, and I know sociocultural educational theory also supports collaborative learning, and you touched upon collaboration as a key component of this. I'm just wondering, though, I've worked a lot in schools and worked from the English language learner point of view, and I know mainstream science teachers sometimes get very particular about working with kids and the sort of skills you need to have to do science projects and experiments. How can we work with mainstream teachers to get them to collaborate with EL teachers? Paula, do you have some ideas and tips?
Yes, and I'll say first that one of the ways, I guess, luckily for us, is that the district that we're working in, most of the teachers are mainstream teachers who their responsibility is to support English language development in their classrooms. They have an ELD time. I know that many different districts are set up differently, but with the school that's sort of our pilot school in this project, they have a 45-minute time, probably 4 days a week, where they are focused on English language development, and the students are redistributed among the teachers at each grade level according to their level of English language proficiency. So that's where we're introducing science as a way to focus on ELD. But what happens is, many of the things, and I think this might begin to address your question, many of the skills that English language learners need to focus on can't be covered in science, and so we have designed the model units to take place 3 times a year, and the other times the teachers have to figure out, well, what are the skills they need to bring into that English language work. But what we hope they will carry across from science into times where they're focusing on ELD are things like the collaborative work, the importance of students working in small groups to solve problems together, the importance of posing questions where the whole class can have discussions together. I'll be talking about this further later, but during those times where they're teaching science, we are supporting them listening to the kinds of ways of expressing their ideas that they might want to work on when they're focused on ELD and not trying to include science, but it's more of a ELD skills time. And we hope that would be the kind of carryover that will happen from science into work with English language development in general. So what I'm suggesting is that when mainstream teachers who are working with ELD specialists, that they look together at the kinds of work that are involved in the science activities and think about, well, when students are talking, how can we maybe listen to the ways that they're talking when they're working in science, and then during ELD time support them with vocabulary work or discourse practices that help, like we're talking about argumentation or giving more detailed descriptions, or the kinds of things that are going to, that science is particularly good at encouraging, and have that be the kind of a new basis for ELD specialists and mainstream teachers to talk about. So it kind of went around the way, but I hope that address what your question was.
Yes, that's very helpful. Thank you so much.
Thank you, Paula. And we can continue on with our presentations. And then when we get to a point, Paula, I have one or two questions regarding strategies that are used to support ELD.
Okay, great.
Thank you.
Thank you. So the next section, I'm going to talk a little bit more actually about the professional development context that we're working in. As I said, we're coming from the standpoint of doing extensive professional development in the Institute for Inquiry around inquiry-based science education. So we got a center grant many years ago from the National Science Foundation to set up a series of workshops that are really geared toward both classroom teachers, but specifically towards people who work with classroom teachers, like professional developers or teacher educators or museum educators. So we have a series of workshops called Fundamentals of Inquiry, Assessing for Learning, and Classroom Strategies for Teaching Inquiry that have been developed over probably the last 15 years. And the materials for that work are available on the web, but what we did is to modify this work and take some of the essences of this work to create the kind of professional development in science education that we feel can support this connection to English language development. So I'll go through some of the foundations of this work to have it out there as a tool for us to think with. The idea that in the workshops we present, we immerse teachers in an intellectual challenge that's driven by their own curiosity. So using that model that many professional development programs in STEM are based on, which is immersing teachers in their own learning, so that they're making sense of puzzling experiences, they're constructing their own new knowledge, they're taking ownership of the process of investigating something, and they're developing a sense of satisfaction that comes out of that. We want teachers to be immersed in that so that they get a sense of how important it is for students' learning, and it allows them to begin to reflect on shifting their teaching. We call this kind of professional development transformative because it really pushes teachers in their rethinking their ideas about learning and teaching. But we also want it to be translatable, and by that we mean to help teachers to come to understand why inquiry is a particularly good way to learn science, and to be able to implement that translation into implementing stronger classroom practices. Even if, and when we do our workshops, and often there are notions out there about what's called sort of a full-blown inquiry or a complete inquiry or a complete inquiry cycle. Sometimes teachers can't do that. Sometimes they can't go all the way through having students develop their own investigation and go through all the data collection and gathering materials and what have you. But there are definitely aspects of the work that you can do that can bring the work into being more inquiry-oriented that we want to really ground for teachers. So that they can take the transformative experiences that help them develop a new vision and motivation for why science is important, why hands-on inquiry-based science is the best way to immerse students in learning science. That helps them to think about the nature of science and think about the nature of their science, learning and teaching. But we've come to learn that grounding in their own learning of science inquiry-oriented way is not sufficient. They need translatable experiences. They need ways to talk about how to sort of develop their own. It's almost an inquiry into inquiry-based teaching, because we want them to develop their own sense of pedagogical principles, what it takes to ask questions in a deeper way, what it takes to set out a plan for an investigation that's really accessible to learners at their stage and their level of academic language acquisition. So we work with them on those types at both of those levels, the transformative work and the translatable work. Those are the essential elements of our professional development approach in the Institute for Inquiry.
Okay.
I wanted to, yeah, there you go.
Oh, thank you, Paula. We're having questions coming in left and right. I understand you've spoken about professional development, and we have one of our participants who's been an engineer technician and has been teaching ESL using STEM materials for 20 years. Now, he has a few questions, but one question, he's been told that new ESL teacher programs require basic science classes as well as their language studies. But how does this particular program address teachers who are science teachers working together with English language learner teachers, as far as creating that collaboration for them to collaborate and affect classroom practices?
Okay, I want to make sure I understand the question. So he's asking about how are we addressing the idea of bringing science teachers together with teachers who are focusing on English language development?
Because you have some teachers who are ESL teachers, but they're required to take science classes. But I understand it's different for every state. But I would like, how do the teachers, or how does the Sonoma Valley Unified School District address this? And how does your program work together in addressing this?
Yes, I'll speak to this a little bit now, and then I hope that where I'm going in the presentation will address some of these things, because that is really our challenge. From our perspective, we are, in the way that our collaboration works, we are science educators who are coming together to work with teachers who have been addressing English language development in direct ways. And some of the things we do to try to address this, or to find sort of the sweet spots for this collaboration, we have the teachers who are not science educators primarily to learn science in a way that allows them to understand that asking your own questions, developing your own sense of how to use materials to find the answers to those questions. Those may sound like general things, but in that, they get a sense of what really makes science an effective situation for the language. So then we back up and we say, okay, you've done this kind of, I'll give an example. We did a balance workshop with one of the schools in Sonoma last fall. And they did a lot of work playing with Tinker Toys and various kinds of toys that help you think about what goes on when balance really happens. And then we had a science talk with them. And we said, well, how do you make sense out of this experience? What are the further questions that you have? And they came up with lots of different ideas about what they might want to try next, why the things they tried didn't work, or why they did work. And we stepped back further and said, okay, well, what kinds of language was involved in that work? What kinds of thinking did you have to do to bring in new kinds of language to make sense of things that they thought they understood about why balance worked? You know, things need to be equal on the same side. Well, it's not as clear as that when you are balancing things when something's not in the middle, or you're balancing things on a Tinker Toy on the top of the bottle. So we use science, sort of understanding those process skills across both the English language development work and the science work, and we have experiences so we can both kind of develop a shared repertoire around the kinds of language work that's involved in understanding science, and then we go from there.
Okay. Now, can you tell us a little bit about the strategies that are used to support ELL's academic language skills in this program?
Okay. Yes, I'll give a couple of examples. One of the approaches that we feel is really important to vocabulary development is that we look at the vocabulary that's involved in a unit and we think about what are the words the students need to understand up front in order to get that unit to be a successful experience for them. And then what are the words that we're going to want to hold on to because they actually are connected to the concepts that students are going to be developing during that unit. So say, for instance, in a magnet unit, we might teach for second grade, we might teach the word magnet because they need to understand, we need to make sure that all students understand that word and even teach the types of magnets we're using, bar magnets or ring magnets. But we don't talk about magnetic force or the word force because we want that to come up through their inquiries, through their investigations, and towards the end when they've done experiences to really get a better understanding of what's going on with the push and the pull with magnets, then we might introduce a word like force. So that's vocabulary development is one strategy. We also, when we go through the units with teachers, we've gotten to the point of having them look for different ways to support, the level of scaffolding that students need for expressing their ideas. So sometimes students might need sentence frames if they just, don't have enough, they just haven't had enough experience with expressing a particular kind of relationship. So relationship between this is more than that, or that is under this. So we would look for places where teachers feel that students need scaffolds for their to get access to their knowledge and to be able to express their knowledge. So that relates to the ideas of comprehensible input. And those strategies might be things like sentence frames, concept maps, I'm blanking on the other strategies, but
and I know what
I'm saying. Using realia, pictorial representations, all those things that might fall under other systems that people use. We think in terms of when are they going to scaffold in helping students enter into the work with the science.
I see. Okay. Thank you very much, Paula. And okay, I'm sorry, my phone muted there for a moment. But yes, and that was the basic question a participant had regarding strategies, and I guess they were looking more for the different approaches to teaching vocabulary to help support ELL's academic language skills, different models that may be used, such as SIOP or guided instruction, but different models that are used or within this program.
Right. And, yeah, so I was just going to say that we're trying to find these general themes that help teachers make the connections between ELD and science. And then the teachers draw on aspects of those strategies, like the ones you're mentioning, SIOP or sheltered English or GLAD strategies, that will support and scaffold the specific activities that students are doing. So it's not that we're using one of those strategies to layer on this. We're trying to create sort of a broader connection around English language development and science because of the resonances with the type of work that happens in both of these, the intellectual work, the cognitive work that happens with ELD and science. And then we work with the teachers as they're teaching the specific units to think about what do you want to draw on from the other strategies. Does that make sense?
Yes, yes. Thank you.
Sure. So shall I move a little further here?
Yes, we'll let you continue, and then we'll bombard you with more questions at the end.
Well, I do hope so, because I think once I get some of the examples out in the lessons that we're teaching, that some of the specific ideas about strategies and so forth can be more grounded.
Okay, thank you.
So here we go. So this slide is just a good way to think about the program structure of our program, to bring in these ideas about professional development. And once teachers get the strong sense of the resonance between English language development and inquiry-based science, the one thing that's really a problem is that they don't have resources, they don't have materials from any particular curriculum that approaches the integration of these ideas in this way. And so one of the things we're doing is developing sort of model units, not a full curriculum, but model units that we believe will support some of the bigger strategies we're addressing around science discourse and writing that I'll talk about a little bit, and then also use as a frame for teachers to look at and say, okay, well, I do need to use some elements of other ELD strategies. And the way that we do this work sort of help them to create the change in their practices by having ongoing follow-ups. We have workshops with them during the year, and then we also have professional development and summer workshops, and then we have ongoing follow-ups during the year where we encourage teachers to bring examples of students' work, bring questions that they have about what's going on in their classroom or how the model units are working so that we can problem solve. But in that process, we're hoping that we are helping teachers shift their classroom practice towards inquiry-based science, but also seeing how to become opportunistic about using science in this theme that I've been trying to build here around using science as a context for supporting academic language development. Here's just a schematic of how this plays out in the district. Our workshops in the summer have this immersion, plus we are beginning to address issues of cultural dimensions of English language development. Then in our study groups, having the teachers examine students' work and bring questions about their classroom practice. How can, say, for instance, something like questioning might be something that we look at. How do they frame the kinds of questions that will help students ask their own questions about the science idea. And as I was saying, we want their classroom practice to really be grounded in these science units. And some teachers are actually using these as a basis to develop some of their own inquiries, so that's been really exciting. To say briefly here that another piece of this is that we're encouraging a group of those teachers within the focal school that we're working with to become teacher leaders in that district, where they help with the professional development work that we're doing. And they particularly host classroom visits of other teachers coming to see how they're using the model curriculum units in their classroom and how they're facilitating more English language development work in connection to science. They also help us in reviewing and refining curriculum units. So I'm not sure if I'm thinking maybe we should go ahead into the next round of things, unless there's a question that really is trying to look at some of the work that I've said so far, some of the programmatic ways of thinking about things.
I think we can move on, and then any other questions? Mari, do you have any questions, or is that okay?
Yeah, that's fine. Let's move on and get more of this good stuff, and then we'll explore some questions.
Okay. So I wanted to dig a little more deeply into the way we're thinking about the curriculum units that we're developing as models and how we're thinking about using them to support classroom practices that we believe bring science and ELD together. So, and we're just, again, here we're at the beginning of the project, but our goal is over the whole project that we'll have 3 model units per grade level in earth science, life sciences, physical science. That these will be what we call guided inquiries, and not sort of full-blown inquiries, but they're inquiries where we might constrain a little bit the types of questions they're asking. And because we're also providing kits for the teachers so that they have the materials that they need. accessible to a variety of teachers. Not all teachers can sort of jump in and in the area of worms or something like that and just have kids come up with all kinds of questions. So we're trying to give enough scaffolding so that teachers feel like they can support an investigation. And we do have a sort of a model, a structure for our lessons this goes across the unit. There might be 8 to 12 lessons in a unit, but through the progression of those lessons, they involve exploring so that students can really come up with their own questions and notice things about the phenomena that's going on. That then out of that, they plan an investigation and they conduct that investigation with materials and come up with data. And that data in some cases might be just observations. If you're working with kindergartners, what they observe about snails is very important for them to then communicate and interpret. If you're working with older students and they've done a study of landforms and they might have very different kinds of investigation, or bottle rockets or something like that they've collected a lot about height and the different kinds of materials that they try to use. But we always emphasize that last piece of having some way of the groups or the whole group or individuals sharing and communicating their ideas. So with that sort of three-step model to guided inquiries, we then go into what are classroom practices that will help teachers to use that model to be opportunistic about using science to nurture English language development. And here's where we know that there's just a sea of the ELD strategies that are out there. And many of these need to go on as teachers help students progress from these lessons. But there are two sort of practices that we've chosen to focus on because we see such a close link between the type of work that you do in science and the type of work that you want to encourage in English language development. And that those are classroom discourse, and we're sort of using the form of science talk as a way to address classroom discourse, and written communication. And we're using the idea of science notebooks as a key way to bring in writing as a way to think about science. So I'll describe a little bit of how these key ideas play out in one of our example units. This is a land snails investigation for 3rd grade. And here's a hint of some of the types of things that go on at each stage. Giving students snails to look at so that they will come up with their own observations, and giving them a notebook where they write and draw what they notice about snail body parts and what they wonder, we're just trying to figure out what's going on with snails. But they're grounded in questions that allow them to write and talk. I'm actually going to go ahead to the slide because I have some examples of this. So in the exploration phase, you can see there's a list that students come up with about what snails look like, what they do. Here's an example of coming up with vocabulary that's closely connected to describing what they see with the snail, and they might be able to use that later when they're working in their notebooks. So when it comes to investigating, there's a sort of a transition between explore and investigate, where you look at what do you notice, what do you wonder, and then how are you going to plan an investigation. For instance, into the idea of what do snails eat. Another kind of question might be, how do snails move on different surfaces? So these are ideas that you have students make a plan. And, here we go. So something like this would be the kind of investigation plan that we've suggested to teachers to use as a model for helping students work in pairs to figure out their plan of what kinds of food snails eat, to figure out the kinds of materials they need, to gather their materials, and they even get down to detail of, well, how can we arrange that food on the tray so that you can sort of tell what the snail might prefer or do with the food, and then watch the activity that the snail does, and write what they observe, what they think they will observe, as well as in their notebooks to write about what they do observe. So one of the things we would emphasize after they go through an activity like that is to come together and have a science talk about it. Well, what did you notice? Why do you think snails move in the way they do on different surfaces? What does that suggest to you about how snails function in the environment? Those kinds of questions are offered by the teacher to the whole class, and then the class is encouraged to look at their notebooks and think about their experiences to say what they believe might be the case. And this is this process of coming to understand how science talk can really support students in looking at their data and talking in the class and making dialogue that supports the whole class and thinking together about an idea is a particularly good way to support their thinking and their drawing on new academic language ideas, new ways of using language to express their interpretation of the data that they're looking at. The science talk can become in different units. It's not always this way that the notebooks are used in exactly this way or science talks are used in exactly this way. But in this unit, it turns out that once they gather this data and they begin to interpret it, they're particularly good times for students to talk about and try to communicate what they're thinking. One of the things that they also do is to create posters that show what they did. Say, for instance, in this one, they created a poster, the class created a poster together of a type of food that the students were going to try. So then the groups would choose, maybe all groups didn't choose all the foods, but they might choose one food from each group or 5 different foods across the groups, and then they have the words are there with the purpose of using them to support the investigation. Okay. So I wanted to show just some other examples. Here is a nice I noticed chart where the whole class worked together to describe, and you can see they're using kind of a sentence frame to support this, but it's all built on the types of observations that students did in pairs with snails. Then they went into their investigation, then they created their plan to draw on the things that they decided they were going to investigate, and then they got to the point of thinking about, this is a group that's making a poster that they're then going to present to the whole group, and they're referring to notes that they wrote in sort of science notebook form, and then they're deciding how are they going to present what they found out to the group. So you can see by the end of this investigation, students have been involved in talking and listening and reading and writing, all of those things that are really important to supporting their ELD and their ELA development, but it's in the context of using the process skills of science, of planning their investigation, asking their questions, following through with their interpretation. So that's the kind of classroom practice that, again, we're building professional development towards, so that teachers can bring this reflection on their own learning to think about how to integrate ELD, integrating science and ELD can support their student learning and create opportunities, particularly for students to learn more English language, to develop their English language development. These are pictures actually from a professional development project that we did with these teachers last fall when we were beginning this project, and these are the teachers that had been involved in our pilot. And we asked them to really step back and think about, well, given all the experiences they've gone through in their learning, how could they reflect and think about what they saw was really going on? And they pointed out things like when students are talking or conversing, they're conversing with a purpose. When they're exploring, they have that purpose. And then that purpose supports the observing and recording that they're doing. These are kind of functions of language that we believe the science uses to create a context for encouraging students to draw on their academic language and to make sense, to use language to make sense of the experiences that they're having. And it was really nice to sort of going through these cycles with teachers where we're immersing them in the professional development, having them play it out in the practice, stepping back and looking and seeing what's happening. So as we go further, that's going through the cycle that I described before, these two pieces that's coming together around the teacher's work and the work with the curriculum in the classroom now leads us to come back to the clear questions that we have. How do teachers who progress through these workshops and study groups and teaching of the curriculum units begin to understand science learning and English language development differently? And how do they use that understanding to focus on discourse and writing practices as a way to help become supportive of English language development? And then we hope, and we've had some suggestions from the early pilot work that we did, that this work will actually help develop students' English language proficiency, and we'll see that in their self-scores and in their academic proficiency, their academic achievement. So that's the whole thing so far, and I'd love to get into more questions that people have. Are you there?
Hello? I'm sorry, Paula. I think my headset kind of went mute there by accident. But thank you so much, Paula. I think we have a couple of questions here, and that actually segues into one of the questions, where creating this community of learning amongst teachers, this also helps a lot of the fears that ESL teachers may have of teaching science. And how does this program help to address that?
Address the fears that
some ESL teachers may have of teaching science, since they feel like they have little experience in STEM, especially when teaching or dealing with force, frequency, and math. And also talk a little bit about the age level and the grade level that you're working with.
Yeah, that's great. We're working with kindergarten to 5th grade teachers. So the science, it's a little bit easier to help the science become accessible to teachers at those grade levels, but there are anxieties about the science. And that is another thread that we try to weave into our professional development, so that the activities that we have them involved in our professional development do two things. One is help them to realize that they can come up with their own questions about science media, and they can do things to help learn science. Because I think part of what makes anxiety for people around science is that they've experienced learning science in a way that's very distant from what they care about themselves and sort of their own ways of entering into thinking about science. So we really immerse in fact, that sort of exploration phase that I talked about, we sometimes call it an inquiry starter. And if we set it up so that teachers are doing just enough with something like playing with parachutes or playing with shadows in just enough of a way for about maybe half an hour, so that they can come up with their own questions. And then we kind of help them frame questions that they can investigate with the materials, and then we sort of facilitate their work with those materials, that they come to some answers of some of their own sort of, not total answers sometimes, but deeper understanding. So part of the way of helping address the anxieties about learning science is to really guide them in a scaffolded way through their own learning of science. And the other answer sort of way into that is with each of the curriculum units that we do, when we reflect with teachers on and set them up for using those units, we have one of our sessions with them will be they've been given sort of homework to read that unit and then come to us and say, well, here's the science that I don't quite understand in this unit. And so we talk through so that they develop enough comfort with the science in the unit so that they feel like they can guide their students in understanding it. So it's a close kind of support in a couple of different ways that we use to address that.
Okay. And I noticed you mentioned a lot about the connection to science. However, could you mention a little bit where STEM fits into all of this? And that's from one of our participants. We just want to see how it all connects, where the STEM fits in all of this.
Oh, and you mean bringing in the technology and engineering and math?
Yes.
Okay. Well, I guess there's two ways to answer it. One is our grounding is in science because we feel that, well, we're a science museum, but also that the ideas about learning science, this kind of inquiry, does apply to all areas of STEM. So when you're working with math, you really want students to be able to, and you want teachers to frame a mathematical problem or concept so the students can get in there with something, with some material, or with some ideas that are accessible to them, to play with it, to come up with their own questions. So we do, when teachers often say, well, you know, it's an issue of actually time. And they say, like, if they can address math along with the science, then they can spend more time on both. So we do help them work on ways to see math in an inquiry-oriented way and to draw out the math in the science that we're working with. Say, for instance, with some of the older grades, they will do more work collecting data and building mathematical thinking off of that. And then we are very opportunistic about our ways of working with technology. When it makes sense to use technology to support a presentation, to support collecting data, to support thinking, gathering information over the web to think through a presentation or to interpret some of the work that the students are doing or preparing for their presentation, say, for instance, then we encourage students to do that. So we kind of use science as a grounding and then bring those other aspects of STEM into it.
Okay, thank you. Now, you spoke about science talk early on. Do you have like a written protocol on how to do science talk, or is it an article describing that?
Yes, actually, we've been drawing on several resources for thinking about science talk, but one of them that is most clear and we refer to a lot in our work is a book called, it's a guide for professional development. I believe it's called Science in Literacy, and the primary author is Karen Worth, and I believe it's a Heinemann publication. We use that, we refer to that model because it describes how science talks and whole group science talks can be set up by setting norms for students to listen, to first take on the question that a teacher engages them with, and to express their ideas in a way that they're trying to make sense of a phenomenon, and listen to each other's ideas, because one of the main things about science talk is that you want to set it up so that, and you have to help students to learn this and teachers to get used to facilitating this way, that the goal of a science talk is for students to share their ideas and do group thinking. It's kind of dialogic thinking. Some people frame it as to come to an understanding about a science phenomenon. So a teacher might, if they're studying sound, for example, a teacher might have them play with a door fiddle or a musical instrument or something for a little while, and then pose the question. So how is this door fiddle making sound? That's one of the examples from that unit. And the students are sitting in a circle and trying to share their ideas about how that happens. So there's a beginning where a teacher gives a focus question. There's a middle where students are sharing their ideas and supported in sharing those ideas in ways that are comfortable to them. And the teacher is trying to bring out more participation in the group, but not evaluation among the group. And then there's an ending to the science talk where the teacher has to make a decision at that point about how to sum up his ideas or reflect back to them the questions that they want to pursue, or draw out from some of the ideas they've had about new things, connections to the next part of their investigation that they're going to do. So there's sort of three parts to science talk. So the beginning and middle and the end. And it's framed very well in the work of Karen Worth. But it's also, there's some other researchers that we refer to, like Accountable Talk, work of Lauren Resnick and Kathy O'Connor and Sarah Michaels. We use some of that work also.
Okay, thank you. And I know we're slowly running out of time, but I just have one more question. There are a couple of questions, and I think one you answered when you started to answer the question of STEM, because another person wanted to find out why math wasn't mentioned. But when you mentioned how it all fits in, I think that pretty much answers that question. However, one participant wanted to find out, how does the inquiry-based method work with students who speak no English?
Does it work with
zero level?
Mm-hmm. They're very low level. Well, the approach that we've taken is that we work with the teachers to draw on those strategies that help students who have very, very little English proficiency to express something about what they're talking about. So we might use a lot of more drawing with students who have lower English language proficiency, or sometimes in some of the classes, particularly they have a kindergarten classroom with very low, students are very new to speaking English, and the teacher in that classroom has enough Spanish, Spanish-speaking as their first language, so that she can sort of use some of their first language as a leverage to help them begin to find some ways of talking about the second language, to find words for expressing their ideas in their second language. It's not a bilingual kind of situation, although there are some schools that we're going to begin to work with this year who are more dual language focused. But I think those are two ways that you can kind of begin at thinking of how can you sort of leverage some of their first language into supporting expression in their second language, but also using as much as you can of ideas or ways of expressing that don't require as much language. Using realia, using pictures, using ways of kids for representing, even physical ways of representing their ideas. It is definitely a challenge, and that's probably one of our biggest challenges. So I'm not going to claim that is something that we sort of have found the key to, but we are heading in some good directions, and we do find that small group work with a teacher is really drawing students into showing in some way, expressing in one word, giving a drawing, pointing to things, and keeping their ideas focused on trying to figure out something, trying to share something. Still, science seems to be a particularly good way for students, even when they have very little English language proficiency, to want to draw on their language capabilities to express themselves.
Yes, I agree. Thank you very much. And I don't know if we have any questions from Mari. Mari?
Yes? Well, this is wonderful stuff, and I'm kind of watching the chat and questions and answers, and it's generated a lot of discussion, which is pretty exciting, but I think we are closing in on the end of the session, aren't we, Katya?
Yes, we are. And that actually concludes our webinar session, because we are getting close to the end. But we'd like to thank everyone for participating. Thank you, Mari. Thank you, Paula. And thank you to all our participants for participating in today's webinar on STEM and ELS, a collaborative effort, and presented by Dr. Paula Hooper and hosted by the National Clearinghouse for English Language Acquisition, NCELA, located at the Graduate School of Education and Human Development at the George Washington University. Now, for those who still have additional questions, feel free to contact Dr. Paula Hooper at phooper@exploratorium.edu, or if you have further questions regarding the webinar itself, please contact Dr. Katya Flemons at kflemons@gwu.edu. The webinar will be archived on NCELA's webinar page on our NCELA website. And to view the archived webinar, please visit http://www.ncela.gwu.edu/webinars. Thank you, and have a wonderful afternoon. Thank you.